Hi everyone, welcome back to another Calculus 12 video. We are doing 9.1 today, which is anti-differentiation. And just so that you know, that's basically just the opposite of what we've been doing up until now. Where up until now we've been working on derivatives or differentiation. So the title says it all, anti-differentiation is the opposite. So let's start off. If we know that f prime of x is equal to x cubed right here, what could f of x be? So this is us working backwards. So if we have x cubed and we know that this is the derivative, this is us like completely adjusting our mindset to go backwards now to think like, how do we normally get to a derivative? We normally take the exponent that's up top, we pull it out front, and then we subtract off a number from the exponent that was already there. So in order to do this, it would kind of make sense for us to do the opposite. So instead of subtracting off an exponent, do you see that we would add on an exponent? So that would give us x to the 4, which means in front of here, it would be like multiplying by 1 over 4. Now let me explain that process, because if I'm thinking backwards of how I got here, if I have an x to the 4 up there and I'm going to be pulling the 4 down in front, for me to end up with just an x here, a quarter must have been there as a coefficient at the start. So let me show you what I mean by this. I'm thinking in order to get x cubed as my derivative, I must have started with a quarter x to the power of 4 in order to end up with the pink stuff as my derivative. Let's think our way through. If I were to take this part, and I'm going to erase this after, I just want you to get where I'm coming from because we're working backwards and that can be a big mind shift. So to take the derivative of this, I would pull down that 4, multiply this out, which would just cancel out and leave me with x. And then I would take away 1, and that's how I would end up with just x cubed, which is actually what we started with as our original derivative. So I a little bit feel like perhaps this was confusing and didn't go quite the way I wanted it to, but I'm hoping that you understood that well enough to be able to make sense of this. The only other thing that I will mention is that, yeah, it could have been 1 quarter x to the power of 4, but there also could have been some other variable there, like, or sorry, not variable, but there could have been some number there. Like I could have had plus 5 there. I could have had like minus 6 there. So basically, if there was a constant there, when I go to take the derivative of it, that constant would then be gone, right? And I would be left with just the x cubed, which is what we ended up or started with as the original derivative. So in order to account for that part, the best way for me to write this would be 1 quarter x to the power of 4 plus some constant c. So this is the antiderivative of this. I'm going to write it in pink. This was the original derivative that we started with. So again, we can go forwards and backwards between these two values in order to work our way through things. So to make this clear, this c value here, this part here, could be, well, c is an element of all real numbers. What does that mean again? Because we're using this formal notation. It just means I could plug in any number for c. It could be any constant. That's all that that's saying. You don't really need to worry about that notation or write it. I just want to make sure that you know that that plus c has to be there. If you hand something in to me and take the antiderivative, but forget the plus c, I'm taking off a mark. So it's important. Okay, so let's do another one. Let's take the antiderivative of, if we have f prime of x equals 2x squared plus x minus 1. So find the antiderivative. In order to do that, well, let's work our way through this. So I'm going to show you going step by step. If we're starting with this first term that's here, so with our first term that's here, we are going to, I'm just going to shove the 2 off to the side, and then I'm going to work within the brackets here to find the antiderivative. So again, this is a mind shift, so I'm going to go through this slowly. We look at this x squared and we now think backwards. So I would add 1 to the exponent that's there. So that tells me that, okay, I must have had x cubed to start with. And then that means that I would put 1/3 in front of it because basically, so I'm going to erase this in a second, but I want you to see what I'm doing here. If I were to take this and take the derivative of it, I get 3/3, which would cancel, and I'd get x squared, which accounts for that part there, and the 2 we had shoved out front. So you don't need to do this stuff in green. I just wanted to make sure that you get the concept because we're doing a huge mind shift here. It's like the complete opposite of what we've been working with. So you've got to wrap your brain around the opposite way of working with this. So then we have this plus x. So working our way backwards from that, we don't really need to write it there, but just to help work your way through this mentally, that's like saying we have an x to the 1 there. You know that doing the opposite or the antiderivative is adding 1. So that would leave me with x squared. But I also need to put a 1/2 in front. So notice that pattern. The the exponent that is up top, I always put that in a fraction in front of the variable that we're working with so that they end up canceling in the end. Okay, and then when we look at this one, if I'm getting -1 for my third term there and I'm working backwards to get the derivative of it, well, I know it must still be a minus, but if I ended up with a -1 in the derivative, that's like saying x to the power of 0. So to work our way through the same like mental process, it would be like saying x to the 0 plus 1. So again, this is allowing us to have a step-by-step process to make sense of how this is working. And then I would bring that out front. It would just be a 1. So I know that I end up with x to the power of 1, which I can just leave as an x. And then I had taught you to make sure that you include that plus c at the end. So then to finish things off, I'd put a plus c there. So after all that work, this is what we would get for the antiderivative of 2x squared plus x minus 1. Okay, so let's take a look then at the notation because I've taught you the scale or we've gone through what this would look like, but we know that our original function is always f of x. If we take the derivative of it, so let's say we did d dx, I'll use that notation, we would end up with f prime x. That you're familiar with, that you know we've done before. Here's the new part. If we do the reverse, we start with the derivative, and then here's the notation for the antiderivative. It looks like a long, skinny, stretched out S. I'm going to start writing my first name using that. And then dx. So this thing here is the symbol for the antiderivative. So when you see that, you know that that's what it is that we're wanting to do with whatever it is that we're working with. And if you would like to see more specifically how this is going to look, here's a quick example. If I have the long, drawn-out, skinny s, antiderivative of x squared dx, that's how the question might look with an equal to sign there. And if we are wanting to take the antiderivative of this x squared, here's how I would give my response. I would look at this and say, okay, I add 1 to that, and I get a 3, so I'm going to put a 1/3 out front. X, and then I know it's a 3 there, and then of course I always put the plus c there. So after working my way through it, I know that that is my antiderivative, and this is the notation and the way that it shows up. Okay, let's take a look at just a variety of examples so you get a clear picture of how this is all going to show up. I'm not happy with that one. Let's make it a little bit prettier. 3x minus 4 dx. So we want to take this and find the antiderivative. And the nice thing, you know me, I like to use this as the guiding tool as we're working our way through things, but basically we can apply all the same types of steps and rules as when we took derivatives, so we can split this up. Like we can take this and say, okay, I'm going to take the antiderivative of 3x dx plus we're going to take the antiderivative of minus 4, I'm going to put it in brackets, dx, and then we can work with them separately. So again, it's I should have color-coded. What am I doing? Let's do it. So like this, so you can see where it's all coming from. That looks awful, minus 4 dx. So if we are working with just the first part here, I can just pull the coefficient out front. So I can just leave that as 3. And then in brackets, again, this is like saying x to the 1. So I'd add a 2 there. And then I would in front put 1 over 2, x to the 2. So I hope by now you're getting the idea of how I'm coming up with that. And then I would have, it was plus minus 4. Do you see that I can just make this minus? Maybe I should do it in purple to keep it consistent, but basically because of this thing here, I can pull out the minus out front, and then if I take the derivative of the 4, again, I could rewrite this to say it's like x to the 0. You don't actually have to write that. I'm just doing it so you clearly see where it's coming from. We could do the plus 1 with it, plus 1. And so then we know that this would be like saying minus 4 to the x, because I don't need to worry about the over 1 over here. It's just minus 4x. And then, of course, we always have the plus c at the end. So after working our way through it, this would be our antiderivative of the original 3x minus 4 that we started with. So by looking at it, oh, I guess I could clean this up and write it a bit nicer because that's not looking so good right now. It's probably better if I do 3 over 2 x squared minus 4x plus c would be my antiderivative of that whole thing. Okay, so then again, I could write this generally. So dot, dot, dot. If I have the antiderivative of f prime x dx, then it would be f of x plus c. And this is the general form, or the general way to write everything that we just finished doing. But as always, what your f prime of x is will change in each scenario. We're going to think and work backwards to figure this out. So let's take a look at some of this stuff. If we have function and we have the antiderivative, here's what it would look like. I'm going to write some out here. 0, 1, x to the n, 1 over x. We'll do e to the kx. We'll do a cos kx. I know this is all scaring you. Don't worry about it. I'm going to go through it with you, and I'll talk about what everything is. So let's start off with this. If we have a function where it's a 0, the antiderivative, again, thinking our way through, it's like me saying, okay, there's like an x to the 0 there, so I'd add a 1, and it would have to be 1, right? If we have a 0 there, it would just have to be a 1 if you think your way through it. And if I have a 1 there, this is where I would have an x to the 0 there. So when I pull it forward, I would end up with just x. If I have x to the n, and I'm going to say n cannot be negative 1, I would get in the general form 1 over n plus 1, x to the n plus 1, just like that. Okay, So then for the next one, if it's 1 over x, this would be ln of x. I'm going to take that one out. We didn't do much work with that. I'm going to take that one out. So then we also could do cos of kx. So this stuff we did do, so it's fine. If we have cos of kx, and I'm going to say in brackets here, k cannot be equal to 0, then as we work our way through this, we already know what the derivative of cosine is, right? So we would get 1 over k sine kx, like this. And if we have sine kx here, and again, k is not allowed to be equal to 0, then I would have negative 1 over k cos kx, working backwards from the stuff that we've done before. Okay, let's take a look at some other examples here. Let's say we have 2x cubed minus x to the 5 over 4 dx, like this. So when we work our way through this, again, we can separate them. So I could pull out this 2 out front and leave that there, and then just work on this term here. So I could do x cubed. I'm going to just do this as I'm going through. I know with x cubed, it's like saying plus 1, and then I'm going to put it over 4 up in front. So the 2 is out front, and in brackets here I'd have a quarter x to the power of 4. So I hope that by now that's making sense to you and you're good with that. Then we have this. We have minus, and here we're going to have, again, it's like I would take this 5 and I would add 1 to it. I'm going to put the 1/4 out front, just like I did before. I'm going to get rid of that because I already took the antiderivative of it, so I don't need to put the symbol there. Let me fix that. So the 2 would be there. Oh boy, 2 would be there. And then here, if I add x to the 6, then I would get 1 over 6, and then I'd get x to the 6, like that. And then, of course, as always, there's a plus c at the end. Don't forget the plus c. And the last step in working with this would simply be to take all of this and simplify as much as we can. So we end up just getting 1 over 2 x to the 4. So that takes care of this. When we simplify these, we get minus 1 over 24. Not much I can do to simplify that. X to the 6, nothing else to work with, plus c. So we would end up getting this. So I hope that that's making sense and it's okay. And your assignment is page 408, numbers 1 to 5, 7, and 8a. So you would end up doing those questions, and hopefully that's enough to solidify these concepts.